your question that I heard about 20 times. What's the camera for? You're not aware. Yes, I'm videotaping tonight's class. You guys will all see it at the end of the class. Okay? All right. This is a great way to learn series parallel circuits, to learn rules and laws, and learn how to apply it. The only problem is, most of the time when we have a circuit full of resistors like that, we don't care a heck of a lot about individual voltage drops. In other words, this work is almost always done for us. This is way too much engineering type idea. Okay? What we care about is picture an elevator print. This guy's a door motor. These two guys are lamps. This guy's a relay. He's a relay. And this guy is a gong. And then here's a fuse. And it's going to be hooked that way. Much, much more realistic. All of them are lit. I don't care how bright, all of them are lit. Okay, so stage number 2. 1 and 2 stay the same. 100 volt. 3 and 4 go out. Number 5 gets brighter.
1 and 2 are the same. 3 and 4 go out.
Number 5 gets brighter.
5 goes. What? 5 is brighter.
5 gets brighter.
Okay, let's say
You sure you got all the circuits?
100 ohms resistance.
Absolutely. Make it as good as the circuit as you can get. When you finish that, give me another.
Hold on. Oh, yeah. What we gotta do? We gotta draw like a print. Stage 1, all of the stage 2. 1 and 2 are the same. 3 and 4 are also fine as well. We flip the switch from stage 2.
Oh yeah.
We like rewire in between each stage?
No rewiring in between stages. The only way I'll let guys rewire in between stages is if they're just stuck and they want to get up on the lamp before the class ends.
Right. I'm trying to figure out how much.
I'd like for you to get it down to 1 if you can. Don't kill yourself to get it down to 1, but I'd like to see it down to 1.
No problem.
You guys pick a number.
Make it good. Make your simple. I got it.
Okay, so instead of having not as bright.
Yeah, but that's only on one. We got
That's one like that.
Now we got these.
This one's gonna stop for this and this, and then the same voltage.
Turn that down and it's all gonna go through there.
So this bulb's gonna be brighter anyway. All the voltage that goes into those bulbs is going to leave both of us. So this will it sounded great.
Higher attention.
They're going to be dimmer. But
You open this up, it's not, it's gonna take you.
This is going to be the brightest thing you want to go to.
This way will work, but these two will be brighter.
Yeah, but now we have to have them all bright.
That's right. This is going to get 100.
Why can't we just etch this out here? Higher ohm resistor here, only one switch, 200 ohm resistor here.
It's actually the same. It should be the same.
You know what I'm saying? Why can't we just get up on this?
Very well.
Once you flip that switch, all four of you
How do we get the resistor?
go ahead. You gotta put this bulb down here. This bulb goes down here.
Can we only, do we have to use just one switch?
No, you want to start off with 2.
How does that switch for? Use 2 switches.
Here's my theory on this one, okay? You think that'll work?
Yeah.
Okay, you drew it on paper. Drawing it on paper is half of the problem. The other half of the problem is correctly putting it on the board. Hold it steady a second.
I don't think it's gonna work.
Give those guys 2 minutes and
Why 800 ohm resistor on it? 3 different stages, brighter, brightest. Now I'm gonna do it.
should I check back with you later?
Yes, you can.
Thank you.
This is bottom one down here. This is this point down. This is where the power comes from. Once you throw it here and here.
Oh, to get.
It keeps going. Now, our power's always in this switch, but then you connect it to here, it'll send it to here, that goes to this.
Yeah, but when we fire up the thing, we want to go from power through 1 to light all 3 of them. The switch is just jumping out the second bulb.
Everybody gets some money up, right?
Power is just going straight.
As long as this is open, it's gonna go straight through now.
Told you not to do that.
Now hit the,
All right, this is what?
what about the switch now? What happens when you, and then the switch to 2?
Bigger, teacher. Understand why you couldn't do it, switch it, you put an 800 and send it to 800.
Anybody need a lab?
Yeah. No cameras. We need a layer.
Don't do both of them at the same time. All right, try that. That's fuse. Fuse ball.
I guess we can't run the
Can't do that.
We could just do switches.
Hi, Mom.
Okay, I just put these with their own power supply. Yeah.
How do we get it? You can use two different resistors to bring it together.
Probably double throw switch. Not running just at one time.
All right, what size am I?
30 seconds.
Bring out the big guy. Okay, Frank. Thank you.
Bring out the big
Come on, Frank. Hey, you got it.
You're gonna end up switching those off.
Right on the bottom. Throw one way, one
You just have to get over to these.
Put it over here.
There you go, you got it.
Oh, there's only one now.
Bring it over here.
Pull it, plug.
You got it.
All right, you go like this. Like this.
What for?
I'm still waiting for you 2 minutes. Count down from 10.
10, 9, 8.
We're almost there. We got it like this far. We got $10 on it. $10
Send us down the street for a couple pictures over there.
Ooh, that's tough. Let's do it.
That's the thing, they get so close.
I'm bleeding here. I'm bleeding. See? I gave blood.
We're not touching the phone.
You there? Brighter. And then let's finish hooking up the last one. I'll show you. What was the last one now? The last one was another resistor. That's what we said. Yeah, the resistor to here. No, but at least it's 750. It's
Do it for the difference though?
Yeah.
That one?
Come on, Steve. He took the cab off and left me.
I'm gonna tell my mom because I'm all you guys.
All the way.
Resistor that allow you to pass through. Well, I tried it once and it didn't work.
We got it.
So far, good.
Come on over here.
You know, we got it. With a switch, and you open it again.
Oh, see, look, they're trying to get the competition.
I want one of these. I want one of these for home.
Look to our shit there.
All right, look.
What's it supposed to do? Phase 1.
Now you just blew the fuse.
We're gonna use 800. That's
But the fuse working. We got it working and he blew the fuse.
Blew the fuse.
Where you put a fuse in, see what blew the fuse. He put both at once and it jumped.
You can't do that.
They were both in there at one time.
Oh, yeah?
And sitting there, I think. That's good.
Building fuse.
Is this a Christmas present? Do you have to buy it for yourself? Yeah, I got it for myself. Something ain't working here.
It's gonna be a... This one's working?
Chris, it was just working. There we go, I found it.
Yeah, all right.
Come on over. Come here.
Oh, wait, this one has to be up first, right? And this one?
Yep.
So what did you do?
I know.
Power source.
The law.
All right, pull them out.
He's dead meat.
You guys own it.
They're all lit.
Five are lit. Here's
Read it up, read it up.
all, first stage. All lit. All lit. All lit. All lit. Okay, all lit. 1 and 2 stay the same. 3 and 4 out. 5 is brighter.
No, I put the other one in too. There you go.
Bingo.
See, 3, 4 go on, they're on, now they go off.
5's always brighter.
You didn't say that they all had to be the
Oh,
same.
absolutely not. I made a point of saying that they didn't.
That's right.
Why are you shaking your head then?
Correct the mundo.
Make a point to tell them plug them.
Okay, we'll go through the other resistors. Power source,
How many volts we dropping each one?
100.
Then I would have 33 in the third on.
On each one. Now, look like something like this. It would look like this with these two being of the same value. Now how many volts on a light bulb? Read ready. Tell me what it's supposed to do first.
Let it rip, Mike.
What's it supposed to do?
3 intensities, one switch.
Okay, this
3 intensities, 1 switch.
200.
1 light bulb. Good.
4 and 5.
What's that voltmeter doing? How are you reading with that voltmeter?
Back to the source.
I don't mean 40 volts or 60 volts. What device on the circuit are you reading?
Oh, I'm sorry. Yeah.
Where?
Go to the fucking
I'm just going to guess and I'm going to hit people.
To the light bulb, from the light bulb, from the resistors.
Right there.
In other words, right now, what's that voltmeter reading?
30 volts.
There's 30 volts applied on what?
Circle the light running.
Okay,
All right, there's 30 volts applied on this light burning.
Right.
Now make the light bulb brighter. Now how many volts are on this light bulb burning?
oh, here.
0 volts. How could you get that light bulb so bright with 0 volts applied on it?
You're actually measuring his resistance, right, or no?
Well, no, it's a voltmeter. But you're reading voltage. What has less voltage?
The resistor.
All right, which one? Are you using them both all the time or just one?
Well, we used one, and then we put one in series when you throw part of the switch. And according to the diagram, we jump it out also.
Nice diagrams. You rewrite these, don't you?
Pretty much.
So the two resistors to the bulb, back to the power supply. Then I'm going to jump in a switch, go from the switch to the opposite side of the resistor. Continue on through the path, and then you have one resistor. And then from the bottom part of the throw, is that right? The bottom throw?
Right.
Okay.
Little part